So there's this new piece of software, the Atomic Kernel, that just dropped its first official version today. And, it's not just some minor update. It's trying to solve one of the most fundamental, deep-seated problems in all of computing: how we keep time.
And this quote just nails the problem, right? Every single one of our devices, from massive servers to the phone in your pocket, has its own little clock inside. And the tricky part, none of them agree perfectly. This is the constant invisible headache we call clock drift. That's not just a dramatic statement. It's literally true. The tiny quartz crystals inside our computers are super sensitive. Even small changes in temperature can make them speed up or slow down just a little bit. And what you get is this constant mess of sync errors, lag, and weird glitches that, honestly, we've all just gotten used to. So, picture this. Our entire digital world is in this endless, frantic negotiation, constantly asking, hey, what time is it really? This back-and-forth guessing game leads to this really nasty type of problem called a state corruption bug. I mean, we've all been there, right? You're playing a video game and suddenly your character gets stuck inside a wall. Well, that's it. That's state corruption. It happened because for just a split second, the part of the game handling physics and the part handling graphics had a tiny disagreement about where you were in space and time. The system literally got confused about itself.
So the atomic kernel looks at all that chaos and just throws the whole idea out the window. Its solution is something they call a software crystal. It's a perfect, rhythmic heartbeat that doesn't rely on fussy physical hardware at all. Instead, it's based on the clean, unbreakable certainty of pure math.
Okay, so that brings up the big question, doesn't it? If every physical clock is flawed by its very nature, how in the world do you build a perfect one? One that's exactly the same for everyone, everywhere, for all time? You'd think the answer would be some crazy, complex algorithm, but no, it's this simple fraction. The entire system's perfect, unchanging heartbeat is born from the mathematical properties of 1 divided by 73.
And the really beautiful part is, the number 73 wasn't just picked out of a hat. It turns out it's the smallest prime number where the decimal part repeats every 8 digits. The system's architecture needed an 8-step cycle, so in a way, the math made this choice inevitable. It had to be 73.
And that is the core idea right there. The software crystal isn't a program that's thinking or calculating. It's a mathematical truth that just exists. It oscillates. It's like a perfect metronome for the digital world, and it can never ever drift, because the value of 1 divided by 73 is never ever going to change.
Okay, so having this perfect clock allows for what is maybe the most radical kind of mind-bending part of this whole thing: a digital world that has absolutely zero memory of the past. I know what you're thinking. That sounds wildly inefficient, right? But think about it like a kaleidoscope. The software crystal is the light shining through it. The objects in the world are like the little colored bits of glass, each with a seed number, and every tick of the clock is just a tiny turn of the kaleidoscope. It doesn't need to remember the last pattern. It just creates the new one from scratch based on the new angle. So yeah, this is a feature, not a bug. When you get rid of memory, you get rid of that whole category of state corruption bugs. The video game character can't glitch through the wall because the math that defines the character and the math that defines the wall are absolute. They're both calculated from the same perfect clock, every single frame. It might be less efficient, but it's mathematically bulletproof.
Okay, but that creates a whole new problem, right? If the universe literally forgets everything, every single tick, how do you prove who you are? How do you have any rules at all? Well, you need a system of governance.
Since memory is off the table, the system leans hard on cryptography. Here's how it works. Every object gets a system ID, or SID, which is basically a cryptographic fingerprint that proves what it is. Then, its object ID, or OID, links the current clock state, that SID, and the OID from the previous tick. What you get is this unbroken, unforgeable chain of identity that goes all the way back to the moment the object was created. And once you have identity, you can have rules. Think of it like this. The rules are split into 2 camps. The lower layers are normative. These are like the laws of gravity. They're just unbreakable mathematical facts about how this universe works. But the higher layers are advisory. These are more like a speed limit sign. It's really good advice, and you probably should follow it, but it doesn't have the power to actually rewrite physics. And to make sure everything stays pristine, the whole system is built on a fail-closed principle. If any piece of data is even slightly ambiguous, or if a rule isn't perfectly clear, the operation just stops, dead in its tracks, no guessing allowed. It's the complete opposite of systems that might fail open and accidentally leave a door unlocked for an attacker. Here, mathematical truth is king. All right, this is where it all comes together. This is the big payoff. We have this perfect, self-governing mathematical universe. But how do you actually prove that your version of it is identical to someone else's, running on a completely different computer? Well, the answer is something you can literally hold in your hand. To prove their point, the developers did something pretty brilliant. They pitted two totally different programming languages against each other. On one hand, you've got Python, which is kind of like a poet. It's dynamic, flexible, creative. On the other, you have Haskell, which is like an accountant. It's mathematically rigid, super formal, and incredibly strict. Getting these two to agree on anything is a really, really high bar.
But that's exactly what the systems test does. It runs the simulation in both languages, and if the final result is different by even a single bit, the whole thing fails. It's a brutal, absolute test of mathematical parity.
And this is the coolest part. At first glance, it looks like a QR code, right? But it's not a link to a website. It's something called an Aztec code, and it contains the raw, compressed data of the algorithms and the rules themselves. This image isn't a pointer to the universe. This image is the universe. And this is where you come in. This is where it gets really practical for all of us. The developers aren't just asking you to trust them. They are literally handing you the proof. Anyone, anywhere, can scan this code, reconstruct the entire digital reality from scratch, and run the math to prove for themselves that it's true. It's a system built on verifiable, accessible facts.
So let's just step back and look at the whole journey we just took. We started with a perfect clock born from a simple fraction. That clock powers a world with no memory, which makes a whole class of glitches impossible. Identity is guaranteed by a cryptographic chain, and it's all governed by unbreakable laws. And to top it all off, the entire reality can be proven true with a barcode that anyone can scan.
I just want to leave you with one final thought. Everything we've talked about, this entire perfect universe, is for a 2D 16-bit world. But if you dig into the project's documentation, you'll find tons of notes on higher dimensional theoretical mappings. So if this math works so perfectly in 2 dimensions, what happens when we scale it up? We could be looking at the blueprint for something much, much bigger.